Welcome! Today we're going to do L'Hopital's rule. It's a lot of fun. It's extremely powerful. It allows us to handle limits like this. So the limit, as x goes to something, of f of x all over g of x, when f is converging to 0, g is converging to 0, we call this 0 over 0, or f is going to infinity at a, and g is going to, well, plus or minus infinity. And this is loosely called infinity over infinity. In these cases, you can't tell just by looking at it what the limit is, because it's going to turn out it really matters mostly how fast they're going to 0 or how fast they're going to infinity. All right. Now, there is a simple case where we can figure out what's going on here with a trick. So if you have f of a equal to g of a being 0, and if the derivatives are continuous there, then you can do the following. The limit as x goes to a of f of x all over g of x, you can do the following. You can add in 0, so that'll be f of x minus f of a. Remember, this is 0, so haven't changed anything. All over g of x minus g of a. Remember, that guy is 0, so no problem there. And then you can add in some denominators. That will cancel. So f of x minus f of a all over x minus a, and g of x minus g of a all over x minus a, because those two here will cancel. And then you can take the limit of the numerator and the denominator, and that's just the derivative f prime at a all over g prime at a. And as long as that's continuous, this is the limit as x goes to a of f prime of x all over g prime of x. Remember, this started out as the limit as x went to a of f of x all over g of x. So in other words, you can calculate the limit of f over g by calculating the limit of f prime over g prime. But remember, this was in the case of 0 over 0. In other words, f was converging to 0 and g is converging to 0. Otherwise, this is wrong. All right, so here's the general statement of L'Hopital's rule. And the setup is you either have to have the limit as x goes to a of f of x is the same as the limit as x goes to a of g of x to be 0. This is the 0 over 0 case. Or they have to both go to infinity. The limit as x goes to a of f of x is either plus or minus infinity, and the limit as x goes to a of g of x has to be plus or minus infinity. It doesn't have to be the same plus or minus. That's called infinity over infinity. Then, if the limit of the derivatives exists, you get the following. The limit as x goes to a of f of x all over g of x is the limit as x goes to a of f prime of x all over g prime of x. Again, only 0 over 0 or infinity over infinity is this legal. But that's L'Hopital's rule. We'll do some examples, actually a ton of examples, in the following videos. Ciao.